Now we're going to introduce a matching algorithm, and this algorithm will allow us to find a maximum matching. For small graphs, we can easily find maximum matching by trial and error. Just visualize the graph, and we can uh, do a little bit of analysis and find a maximum matching. For larger graphs, we need an algorithm. Well, we're going to use the matrix, the bipartite matrix of a graph. So this algorithm works only for bipartite graphs. Now remember that we define independent set. That's a set of entries of the matrix, a set of selected ones that corresponds to a matching in a graph. And the goal here is to find a maximum independent set of ones. Now here's what we're going to do. Let's say, for example, we start with this matrix. Now the underlying graph here, as you can see, is a bipartite graph, and there's an edge from 1 to A, an edge from 1 to C, 1 to D, and so forth. And here the star indicates all the stars indicate a matching. Remember, we cannot have more than one star in a line, either in a column or in a row, because then that would not be an independent set of ones or a matching. We interchange the words independent set of ones and matching because those are equivalent. Independent set of ones is those two ones here. They represent an independent set of ones. But in the underlying graph, it's a matching. It's the edge. It's the set of edges 1A and 2B. So we're going to work with the matrix. Now, the algorithm will give us two things. One of the two things at the end of the algorithm. It will either give us a matching that has more edges, one more edge, or one more star, or it will not improve anything, which means that what we have now, it's already a maximum independent set of ones, a maximum matching. So that's the purpose of the algorithm. The algorithm itself doesn't give us the maximum matching, a maximum matching on the first try. It may take several tries of the algorithm until we have no improvement, and then that indicates that it's a maximum matching. Okay, so there are two operations when we perform the algorithm. There is the operation of labeling and the operation of scanning. We cannot label before we scan a row, column or a row. Once a line here means either a column or a row, okay? Once a line is labeled or scanned, it will not be labeled or scanned again in one application of the algorithm. All right, so here's step number one. We start with a matrix, and we need to start with a matching. You could start with just one edge, or two edges, or even no edges. But it would be better to start with the most number of edges or most number of stars possible. This way, the algorithm will, with several applications of the algorithm, will get to the maximum matching quickly or quicker. Okay, step number one is to label columns that have no stars. So here we're going to label column C down. We're going to label at the end of the column with the pound sign here, and same with D, because those two columns do not have the stars, do not have those starred ones. Now here's one thing: if there are no starred. Um, if all the columns have stars, then there's nothing you can do. It's already a maximum independent set. It's already a maximum matching. So here we start by labeling C with a pound sign, D with a pound sign. And here's step number 2. Step number 2 is a loop. Step number 2, we're going to be scanning columns and then rows, and then columns and then rows. And we keep doing that until we reach, I'll show you what's going to happen at the end of step number 2. Okay, so and step number 2 has 2 sub-steps. Step 2.1, we're going to scan a column. Those 2 columns that are labeled with the pound sign. Now, when we scan, every time we scan, we look for something. This time, we're going to look for unstarred ones. We look for ones that have no stars. So here we go, going to go down, start with C. Let's go down, scanning it. And here we found one that has no star. When we find a one with no star, we're going to label that row with the current column that we are scanning. So here we found one. We're going to label that row. Remember, we're scanning a column, so we're going column C row 1 and column C row 2, row 3, row 4. So we're going from the top to the bottom. And every time we find a 1 with no star, we're going to label with the column. So here we found 1. We label that row with 1. There's no more ones, then we put a check mark indicating that this is already scanned and done. Now we move on to the next column that has a label. Then we're going to go down and we try to find ones with no star. Here again, there's another one with no star. And we would label this row with D, but it's already labeled with C. So we don't label, we keep going down and we check mark column D, indicating that it's done. Now all the columns have been scanned and checked. Now we're going to turn to rows, and that's the second sub-step of step 2. So now we're going to scan rows that are labeled. And when we scan the rows, we're going to look for ones with stars. So you can see how it flips. When we scan a column, we look for ones with no stars. When we scan a row, we look for ones with a star. Here we're going to scan this row, row 1, and we find one with a star. Because we're scanning from left to right, we're going through each column of this row 1. So once we find a 1 with a star, we're going to label that column with the row. So here we found 1 with a star, so we're going to label down here with 1, indicating that we found a star at row 1. And then we keep going. Here we found, we label here with 1, and we keep going, and there is no more stars. And we check mark, indicating that it's done. That's the end of step 2.2. Now we're going to go back to step 2.1 because we now have a new column that is labeled but not scanned yet. So we go back to step 2.1. We're going to scan this column and look for ones with no star. When we go down, here's one, but it has a star, so we don't do anything, just keep going down. And here's one with no star. That means we're going to label this column, this row here with A, indicating that we found a one with no star at row 3, so we labeled row 3 with A. So it's like flagging row 3 with the column that we are scanning. So we are done with this column. There's no more columns to scan, but look at that. Now we have a row that we need to scan. So now we go back to step 2.2 because we have a row that we need to scan. When we scan a row again, we scan for ones that have stars. Okay, so let's go here. This one has no stars, so we don't do anything. Keep going. One with no star, don't do anything. Keep going. Well, there are no stars. If there are no stars, then this indicates that the algorithm will give us an improvement. So we label that row that we're scanning and that has no stars, we label that with an exclamation mark, exclamation point. And this tells us that we're about to get an improvement. We're about to get a matching or an independent set of ones that will have more ones, more stars. And that's actually step number 3. It's called backtracking. From the exclamation point, we're going to follow the labels and circle the ones that we find. So this is how it works. Here's the exclamation mark. The label here is A. So let's go in this row 3. Let's go to column A. Let's go column A, and we're going to circle this one here. At this column, now look at the label. The label tells us to go to 1. So let's go row 1. In row 1, we circle that 1 there. And at this row here, we'll look at the label and this tells us to go to row C, to column C. And we circle that. In column C, now we have the label is a pound sign. It means we stop circling. Okay, so just to repeat that, we start with the exclamation mark. The exclamation mark tells us what to circle. We go to the point, to the entry that we need to circle. Go to A. Here, look at the label, go to 1. Here, look at the label, go to C. Here, look at the label, stop, because it's the pound sign. So we circle these 3 entries. Now we're going to reverse the stars and those stars. In these 3 circles, if you have a star, you delete the star. If you have no star, you put a star. And that's going to create a new independent set of ones, a new matching. See, we flip. See, no star, no star, with star. Now we flip. And here is now no star, and then we got the 2 stars. And this is a matching that now has 3 edges, right? Edge 3A, 2B, and 1C. So the algorithm gave us an improvement, a matching that has 3 edges.